Hello, everyone. In this session, we will be talking about simplifying capacity management of EC2 instances using autoscaling. Now, this is a very interesting topic since there are multiple dimensions to the elasticity that the AWS cloud offers. One of them being the ability to provision hundreds and thousands of instances in no time without any upfront capital expenditure. Another dimension is the one that we will be talking about in this session, which is around automatically provisioning and managing your EC2 instances without giving you a completely hands-off experience. My name is Anup Kapoor. I'm the Senior Product Manager for the Autoscaling service, and my goal is to help customers maximize their application performance while lowering costs. Now, at times, there's a misconception that EC2 autoscaling is just about adding or removing capacity as and when the traffic to your application changes. But that's not quite true. There's a lot more to it than that. We have customers who manage 100% of their EC2 instances using EC2 autoscaling. So I'm going to go over the 4 popular use cases that EC2 autoscaling solves for our customers, and then throughout, I will be highlighting several new features and capabilities that we've recently launched. And then we'll hear from Netflix how they are using autoscaling. So just wanted to mention real quick, this is a very special year for us. We are celebrating EC2 Autoscaling's 10th birthday. And for the last 10 years, EC2 Autoscaling has been standing by its customers and been letting them have better sleeps by doing the heavy lifting of capacity management on their behalf. So the first use case, automating the provisioning of instances. Now, when you use EC2 autoscaling, you will be hearing the term autoscaling group or ASG a lot, and you will be using it a lot. So an ASG is a logical group of instances. So say, for example, you have a collection of instances which is running the front end of your website. All those instances will be a part of one single autoscaling group. The ASG is bound by the maximum and minimum capacity. So the ASG is not going to go above the max. So you don't have to worry about cost overruns or runaway scaling. And similarly, it will not go below the minimum either. And then desired is what determines what are the number of instances that should be running in the ASG at any given time. So ASG will either launch instances or terminate instances so as to meet the desired capacity. Now the question becomes is, what are the properties of the instances going to be that are launched in this ASG? So that's defined by the launch template that you associate with the ASG. The launch template has all the properties, for example, what instance type should launch, a C5 large, an M5 large. What is the machine image it should launch with? If you're using golden images where you're baking all the software in a custom AMI, this is where you end up specifying the custom AMI as well. Now, if you're an existing autoscaling customer, you must be wondering, why is he talking about just launch templates and what happened to launch configurations? So launch templates are an EC2 construct, which were launched back in 2017, and launch configurations are an EC2 autoscaling construct. You can think of launch templates as very similar to launch configs, but being on steroids. They can be versioned. They've got support for all the latest EC2 features like T2 Unlimited, EBS tagging. And what we're seeing is a number of features that I'll be talking about today that we've introduced. They are available when you're using launch templates. So moving forward, launch templates are the way to go. So would highly encourage migrating to them. So once you have this configured, once you have the ASG and the launch template, that forms the blueprint. And then from there on, everything is automated. ASG is also fully integrated with elastic load balancing with all 3 classic load balancer, application load balancer, and network load balancer. So whenever an instance comes up, it will automatically get registered behind the load balancer. And then when the instance has to be terminated, it will end up draining the instance and then deregistering as well before the termination. Now, yesterday, we were very excited to launch the support, autoscaling support for dedicated host. Several of you might be already using dedicated host. So dedicated host, they have a very popular use case when you're bringing your own license to AWS. And essentially, you need access to the whole box because of your license obligations. So we are doing this through AWS License Manager. And we've introduced this new construct, which is the host resource group. So the host resource group is a collection of dedicated hosts. It's pretty dry in Vegas. So it's a collection of dedicated hosts, and you create a host resource group, and then you end up allocating some settings, for example, what the host allocation policy is going to be, the host release policy is going to be, what should happen if a dedicated host fails, the auto recovery functionality of it. So once you've configured this host resource group, this is what you end up specifying in the launch template as well. What else does this capability come with? Now you can launch, if you're using Nitro instances, you can launch multiple instance sizes within the same family on the same dedicated host. With the automatic allocation and release of hosts, you can better utilize your savings plans as well. And you can do cross-account sharing. So you can have one common dedicated host pool for all your organizations. So the intent of these features is that you be able to better utilize your infrastructure, your dedicated hosts, and in turn and even your licenses, and then in turn be able to lower your costs. So let's just take a look at a quick example how this works. So say you have an ASG which has to launch a C5 extra large instance. Now to begin with, there is no dedicated host available. So it ends up automatically allocating a host, and then will end up launching the instance on it. Now say another ASG comes in, it's got to launch a 2XL instance. So now it sees that the dedicated host is already available. It's got capacity to launch a 2XL instance. And once again, note that the same dedicated host can launch the extra large and 2XL instance on it. So that gets launched. And that's how all the subsequent launches will work as well. When the terminations have to happen, so say the M5 4XL has to terminate, that goes away. When the M5 extra large has to go away. After that, the dedicated host is completely empty, not required. It will automatically end up getting deallocated and released. So that was auto-scaling for dedicated hosts. Now, another very exciting feature that we just launched a few weeks ago was the ability to automatically recycle instances at a regular cadence. So all you've got to do is specify the max instance lifetime parameter in the ASG. And then ASG is going to do the heavy lifting of doing the replacements of the instances before they hit that time. So you don't have to worry about too many replacements going on at the same time, because ASG is going to end up spreading them out. You may want to do this for security reasons, for compliance reasons. But when we launched this a couple of weeks ago, I saw a lot of customers, they were talking on different forums about this functionality. And there was one common theme of excitement, which was that this is the solution to the problem of memory leaks. So I hope several of you can relate to that as well. If anyone was wondering what the magic number 604-800 is, it's just 7 days and seconds. So now that you have the capacity provisioned, the next is, how do I reduce the paging frequency? And what that means is, if anything were to go wrong with my EC2 instances, how do I let auto remediation happen? That means go cure my instances without any manual intervention. So ASG is integrated with both EC2 health checks and ELB health checks. If ASG detects that anything has gone wrong with the instance, if the health check has failed, it automatically detects that and then is automatically able to replace it. That's why we see that customers who are launching even one instance, they will end up placing that in an ASG and let it be managed by an ASG for this functionality alone. Now, from an AWS well-architected perspective, one of the best practices is to have your EC2 capacity across multiple AZs. And the reason is, if anything were to go wrong with one of the AZs, you still have capacity in the alternative AZ. So ASG does that for you by balancing the capacity across AZs. So in this case, if you've got 6 instances, it will launch 3 instances in one AZ and the other 3 in the other AZ. And if anything were to go wrong with any of the AZs, it detects that and is able to automatically retarget your capacity to the healthy AZ. And once it's done that, it continues to poke the constrained AZ. And as soon as a launch in that AZ is successful, it will once again end up rebalancing the capacity across the AZs that you've specified. The third use case is around making it super simple and easy to use Spot instances. What are Spot instances? Spot instances are EC2 spare capacity, which are available at a very discounted price, up to 90% off of on-demand prices. The infrastructure, the platform, the performance, everything is identical to an on-demand instance. The one difference being that if we need that capacity back for on-demand usage, we will give a 2-minute notification and we'll take the instance back. But with auto-scaling groups, they having the capability of being able to provision multiple instance types across multiple purchase options, that's what makes it super ideal to manage your Spot instances as well. So all you've got to do is 3 things. You select the instance types that work for you. You select the Spot allocation strategy. You can tell ASG, okay, just go and launch instances in the pool which are the cheapest. Or you can use the newly launched capacity optimized strategy, which makes the most efficient use of our spare capacity. It looks at the real-time capacity data. It's able to make predictions on the availability of the pools, and then it will accordingly end up placing it will make the launches on those pools. And the idea being that that should reduce the interruptions that you face. And then the last thing is you specify the percentage split between the on-demand and the Spot portions. A couple of weeks ago, we also introduced the capability of assigning instance weights to the instance types that work for you. So in this example, you can see that I've assigned the weight to be the same as the number of vCPUs that the instance types have. So essentially, instead of the ASG now requesting capacity in terms of instances, it's going to be requesting capacity in terms of cores. So this gives you even more flexibility to be flexible across different instance types. So this is what the JSON for the mixed instances policy looks like. The 2 very interesting things to note here are the 2 parameters, the on-demand base capacity and on-demand percentage above base. This is what defines the split between the on-demand and the Spot portions. So these 2 parameters, they give you a lot of flexibility. If you need 100% Spot instances, you can do that. If you want 100% on-demand instances, you can do that. Why would you want to do that? Just to have backup instances. For example, if an instance type was not available, you still will be able to launch a backup instance type. If you want to just have a percentage split between the 2, you can do that. So what I've seen customers do is they'll start with, when they are just starting out with Spot instances, they will set this as 5% Spot instances. And as they get more comfortable with Spot and as they understand that better, they'll just end up increasing this number. And if you just want to define a base on-demand capacity and then you want to turbo boost your application with Spot instances, you can do that as well. We do have a Chalk Talk coming up for this on Thursday, so we will be doing a deep dive on this session. And then I do have some $50 Spot credits. If you want to try it out, more than happy to share that. Now, the last use case I want to talk about is the ability to automatically scale out and scale in your infrastructure as the load to your application changes. So what that means is I don't want to provision for peak capacity at all times for adequate application performance. I don't want to be paying extra when I don't need that capacity. I don't want my application to have sluggish behavior because of having not enough capacity. So this all goes back to the concept of the minimum, maximum, and desired that we talked about earlier. So the question becomes is that what should these values be set to and how should they be set? So the easiest way of doing this is by just doing manual scaling. You just go into the console or the CLI API, and you just update one of these parameters, and then ASG is just going to conform to the new settings. The second is schedule scaling. If you do have predictable patterns where you want to have capacity like 9 a.m. to 5 p.m., and then you want to shrink the capacity during evening and nighttime, then you can do that with schedule scaling. There's full support for cron expressions, so you can build whatever you want. The third is dynamic scaling with target tracking. So this works just like a thermostat or a cruise control in your car. All you've got to do is pick the metric that you want to scale on, for example, the average CPU utilization, and you set the target for the metric. So say you know that the application works well when the threshold is around 50% CPU utilization. That's what you set the target at. And then from there, target tracking does all the work. So you've got traffic coming into your application. The target is at 50%. If more traffic starts to come in, the CPU utilization on the instances is going to go up. Say it rises to 75%. From there, target tracking is able to calculate that, yes, I need another 5 instances in this case to be able to bring the CPU utilization back down. So it ends up launching the 5 instances. Once again, everything is happy, and everything's good to go. So what we see is that for the most part, target tracking works extremely well. But if for any reason you do need finer grained control of your scaling policies, you want to set your own alarm thresholds, you want to set your own steps, for example, add 2 instances when the alarm reaches 60%, add 4 instances when it reaches 70%. If you do want to have that granular control, you're more than welcome to use step scaling policies as well. And the last is predictive scaling. So with target tracking, what we saw was that it responds to the changes in traffic. So once the changes happen, then it provisions capacity. But we've got customers who say that we want to pre-provision the capacity. There could be 2 reasons. One is that they just have predictable patterns, and they want to pre-provision the capacity. The other is that the bootstrapping times could be longer. And for that reason, they just need to do it quicker. So with predictive scaling, it takes a look at the data of your application for the last 2 weeks, and then based on that, it ends up predicting the next 48 hours of the traffic. And then it can run a regression model on it and understand how much capacity would be required in order to cater to that traffic. And once that's done, it just ends up setting up schedule scaling actions, and that's how the capacity is provisioned. And this works extremely well with target tracking, because what predictive scaling does is it just ends up setting a baseline, and then target tracking can go and fill all the gaps and valleys and all the fine-tuning above that. With that, I would now love Netflix to come and share with us how they operate at the scale at which they do using autoscaling.
No.
Can you hear me now? Okay, sorry about that. All right, thanks for coming. I know it's the last session. I'm the one who's standing between you and your dinner. I'll try, I try make your time